Equations of parallel and perpendicular lines in the coordinate plane. The purpose, this lesson will teach me to identify slopes of parallel and perpendicular lines and write the equations of parallel or perpendicular lines when given a point. Describing parallel and perpendicular lines. Parallel lines are coplanar lines that never intersect. The definition of coplanar means a line in the same plane. Perpendicular lines are lines that intersect to form right angles, and again, right angles are always 90 degrees. When we deal with parallel, this symbol is generally two slanted lines, and in perpendicular, it looks like this. Slopes of parallel lines. Slopes of parallel lines are the exact same. So for instance, if you were given something had a slope of m, the line parallel to it would be 3. If you had a slope of -1/2, the slope parallel to it would be -1/2. And if you had a slope of 3/4, the slope parallel to it would also be 3/4. The idea that because the lines will never touch, their rise and their run must be the exact same in order to keep it so they won't ever intersect. The slopes of perpendicular lines are a little bit harder. It needs two conditions. They need to be opposite, meaning one positive, one negative, and they need to be reciprocals. This is when you flip a fraction upside down. So for instance, if we had a slope of 3 and I wanted you to talk about the line that is perpendicular to a slope of 3, think about 3 as a fraction. It's a positive 3/1. So its opposite would be a negative and its reciprocal would be a 1/3. So one is going up 3/1, up 3/1, up 3/1. So picture a line going this way. The other one's going negative, down 3/1, down 3/1, down 3/1. So they'll intersect to form the 90 degrees. Looking at another example, if I had a slope of -1/2, its perpendicular slope would be a positive, now flip that fraction, 2/1. And lastly, if I had a slope of 3/4 and I wanted to make it perpendicular to 3/4, it would be the opposite and flip that fraction upside down. All right, so in number 3 it says, will the graphs of each line be parallel, perpendicular? Actually, this is number 3. Will the graphs be parallel, perpendicular, or neither? So in order to be parallel, they have to have the same slope. Perpendicular, opposite, reciprocal slope, and neither is just none of those two clauses. But in order to determine slope, we need to get the equation of the line in y equals mx plus b, because from here we can identify slope. If you look at letter A, here's your slope, it's 2. And in the second equation, here is our slope, it is also 2. So because these are the exact same number, that means that the lines will have the same rise over run, so they'll never touch. So these lines are indeed parallel. An idea of explanation is that they have the same slope. Looking at letter B, neither the equation of the first or the second is in y equals mx plus b. So here's the y, and in order to get it by itself, I need to first move the -6x to the other side. So I have an 8y equals 6x plus 24. From here, we're able to divide everything by 8 because the 8 and the y were held together with multiplication. Y is equal to 3/4 x plus 3. So your slope for this first line is 3/4. Looking at the second equation, I have a y plus 7. So in order to get that y by itself, I'm going to subtract the 7 to the other side. Y is equal to 4/3 x minus 7. So in order to be parallel, the slopes need to be the same. So they're not parallel. In order to be perpendicular, we're looking for two things. One, they have to be opposite in sign, meaning one positive and one negative, which that doesn't appear to be the case because we have a positive 6/8, so we have a positive 3/4. The other thing they need to be is reciprocals, meaning the fractions need to be upside down. If you look at 3/4 and 4/3, they are indeed reciprocals, but they're not opposite, so that means they're not perpendicular. These ones are going to be neither. These two lines are lines that intersect, but they don't have any special relationship, meaning they're neither perpendicular nor parallel. All right, so for number 4, it says write the equation for each line given the information. You can write the equations of your line in either slope-intercept or point-slope. I think most of you prefer slope-intercept. So it says write the equation of the line that contains the point 2, -6 and is parallel to y equals 3x plus 9. So let's just get a quick visual. So we have the point 2, -6. Let's see, where is it? There it is. See it down here in red? And we have the line y equals 3x plus 9. All right, so if you notice, we have the line in blue and we have the point in red. And what this question is asking is that I want a line, I want you to write me the equation of the line that goes through this, that goes through the red line, or I'm sorry, through the red point, but is parallel to the blue line. So if you can kind of get an idea, I can't really write on this from where it's at, but if you can kind of get an idea, it's going to be coming in through here somewhere. So it's going to have the exact same slope. So when we go back to thinking about how we're going to write our equation in slope-intercept form, if we think about y equals mx plus b, it's going to have the same slope as this line in order to be parallel to it. And if I want it to go through that given point, so again, kind of giving you a sketch, we were at 2, 1, 2, 3, 4, 5, 6. So the point was down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3 over 1. Okay, so there's the y equals 3x plus 9, and here's that 2, -6. So I want it to come in here. So it's got to have the exact same slope. And in order to go through this point, well, what that's going to give you is the x and the y. So here's the y, and here's the x that we need in order to solve for where it's crossing the y-axis down here. So we have -6 equals 6 plus b. In order to get the 6 to the other side, we subtract. B is equal to a -12. So the equation of the line is going to be 3x minus 12. And if you think about it, if this is down here at -6, is that point, yeah, that one's going to have to be significantly lower. And let me toggle back over here to this other screen. So our answer was y equals 3x minus 12. Yep, if you notice, we have the blue line, which was the original line that was given in the problem. We have the red dot. You can kind of see it. I'm flashing that red dot down there. So that's 2, -6. And so the green line is both parallel to the blue and going through the red dot. Let me show it to you real quick, work-wise, using the other method. Everything's the same. Our slope would still be 3. We'd use this point as our, really it's the x1 and the y1. So it goes y minus the y1 value equals m times x minus the x1 value. What I like about this particular method is that as I go through and distribute and I move this 6 over, y equals 3x minus 12, my answer kind of pops out at the bottom, as opposed to this method, you end up with a b and then having to plug it back in. All right, so let's try this next option here. It says write the equation of the line that contains the point 6, 2 and is perpendicular to -2x plus 7. So let's just get a quick visual. In this problem, the point that we need to go through is 6, 2. And the line we need to be, in this case, perpendicular to. All right, so I need to make a new line, and it needs to go perpendicular to the purple, but it has to go through the orange. So if you can kind of picture this line in through here, again, I can't draw, I'm trying to use my arrow. So in order to be perpendicular, we need the line to be both, we need the slope to be opposite, and we need it to be reciprocal. So if this is the given slope, the slope opposite to that is a positive, and the reciprocal of that is 1/2. So that when we go to do y equals mx plus b, we're not actually using the -2. That would make it parallel. In order to make it perpendicular, we need this one right here that is opposite and reciprocal. They're giving us the 6 and the 2. So 2 equals, plug all that in, and from here we should be able to solve. -3 minus 3, b is equal to -1, so y equals a positive, and I guess you don't need to write the positive, positive 1/2 x minus 1. So let's just double check. Let me get back over to my grapher here. So we had a y equals 1/2 x, what was that? Minus 1. So if you notice, the black line is that new line, the equation that we just wrote. It is perpendicular to the purple, and it's going through that orange point, which is exactly what we wanted. If you want to see it the other way, again, kind of going the same way, we would use that opposite reciprocal slope, which is a positive 1/2. So I would have y minus my y value equals m times x minus my x value. And again, what I really like about this method is that when I'm done, the answer is just right there, and I don't have to do anything else to it. So same answer. All right, we've got one more problem. It says, are the two lines perpendicular? Show, work, or describe. So we need to find the slope, and here's line L3. So rise 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So I said 4 over 9. Now the slope of L4 is this one here. Down 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. In order to be perpendicular, they have to be opposite, meaning 1 plus, 1 minus, which they are, but they also have to be reciprocals, meaning flip the fraction upside down, which they're not. So are they perpendicular? No, they aren't perpendicular. Show, work, or describe. Well, I did that verbally, but there's your work, counting your slopes, and your description would have to do something that they're opposite, but they're not reciprocals. So that should conclude your notes. Please let me know if you have any questions.